Today we are going to be talking about chapter 10 and basically re-expressing our data. And first I want to get into why we would want to re-express our data. So, the big question always in everything that we do is why? Why is this important? Why would we want to re-express our data? Well, first things first, the number one reason that we re-express our data, it is much easier for the average person to comprehend a one-on-one relationship than um, uh, comprehend a linear relationship than a parabolic relationship. Let's say that, for example, right? Not everybody is going to be in the realm is like, yeah, I took physics. I get that. I understand that. Not quite. There's a lot of things that we already express and we already manipulate um, today, um, just if in forms of a one-to-one relationship, so that we can, as either a consumer, as or an average day person, understand. So, example, if you know anything about guns, right? Well, we measure guns in terms of gauges. So, for example, it is easier for us if you were to have a gun and they say, oh, this is a 10 gauge gun uh, versus a, let's say, 20 gauge. And we're like, okay, what does a 10 gauge and 20 gauge? Well, a 10 gauge is technically 0.775 inches in circumference, and a 20 gauge is 0.615 inches across. And we're like, okay, that's it's different, and we don't know how to quite analyze that. So it's easier for us to measure, um, to think about in terms of 10 and 20 versus 0.775 and 0.615 inches in terms of gauges. Other examples, that things that we use to manipulate all the time. We put storms in different categories just to make it more of a linear relationship, right? For examples are tornadoes, right? We have F1s, F2s, F3s, F4s, and then if it's an F5, we're like, oh, that's a really big one. Well, each one has a range and everything, but we put it in this simple linear relationship uh, just so that we can understand it a lot easier than if saying, well, the relationship kind of is difficult. It's based on the wind speed and the size and velocity. So, all of those in mind, we can say, well, that tornado, we got an F2. Not as bad as that big one over there. It's an F3. That's going to take down a town. Other things to think about when we are re-expressing our data to so now we say, okay, re-expressing is data. It's easier for us to understand it if it's linear, but when we have to be careful when we see data, because when we see data and it's a normal scatter plot like this, right, and let's say it has a high relationship, it could be a high relationship and like that. But if we put a straight line through it there, it looks like this might be a linear relationship. However, what we want to do when we re-express the data is we want to use the residuals in terms of the data, because if we put it in terms of a residual data, this particular set of data actually becomes even more apparent to us that is actually very much so parabola. So it's a parabolic relationship. So when we are re-expressing our data, we aren't using the variance. We want to use the residuals form of the graph. Lastly, there are some graphs uh, that we should not use, we should not try to make linear. So if we are given a data and the residuals all look like this, it is all over the place and with a straight line through, this does not have any relationship. It's all randomized. There doesn't seem to be a clear straight relationship. So we should not try to make alter the data in any way. Altering the data won't help. We won't make it any more linear uh, in this particular instance. Another particular instance is if we had a data that curves more than just one way, right? If we had one curve, if we have one curve, then it could be a log, it could be a parabola. But if we have multiple curves like this is going to be difficult. This is going to be difficult, and you really can't make this line the residuals straighter, doing any type of uh, manipulation. So no, we should not do this. Secondly, any relationship that is cyclical, okay? Any relationship that is cyclical, so anything that goes in cycles, we should not try to strain out that particular data. So if let's say if you were measuring the height of the water in terms of like yearly water height in a particular area, that relationship is cyclical based on the tides, right? It is cyclical between January, February might get a little bit higher, but then the relationship gets lower, but then it will get higher again as it falls. It might get lower, but then it will get higher again, right? Like that. If it's a cyclical relationship, just like that, then no, we should never try to put that in terms of relationship in straighten out that particular plot. Other cyclical relationships, anything that comes in a cycle pattern. So tourism, right? If you want to measure, try to straighten out your data in terms of profits based on your yearly tourism income, well, that relationship is cyclical because there's going to be seasons when there's going to be more people coming to your area versus seasons that are not. So the numbers are going to change throughout each time. So in that case, you should not try to strain out the data. But let's talk about times when you can turn. So every other time you can try to strain out the data. So if the data kind of looks like any other, like a function, if it looks like a parabola, right, then yes. If it looks like a parabola, then yes. If it looks like it's just kind of scattering, and then maybe it's kind of going somewhere, but it's scattered but yeah, you can mess with that. We can work with that data to try to make it better. Yeah, of course. So yes, if it is, even a logarithm or in an exponential rhythm, like down here, like this looks like a decay curve, then yes. So if it's any normal function that you have seen before where it's just one particular curve, then of course we can try to make that, like say this looks like a curve here, right? This looks like this might be a logarithm, then yes, these are all types of graphs that we could make a data from.